Hello everybody and welcome back to this week's Easy 11 Plus live lesson. I've had a break for a couple of months with a young baby, but I'm now back and doing these lessons and I'll be here most Tuesdays as normal at this changed time of 6:15, which I'm going to be sticking with for a little while because I'm teaching a lesson just before. And that's the other very important bit of news for anybody who doesn't know, that I now do tuition after people have been asking me to do it for some reason for years. You can join my lessons if you go to the RSL Educational website and go to the tuition page, and there's a calendar there where you can see what I do and sign up for my lessons. The lessons are mostly comprehension and creative writing, and you can join there. Hello to everybody who's been writing comments. There's been some very confusing Gen A nonsense language from 11 Plus Network. I'm not going to read it out just in case it's rude because I've got no idea what it means. I'm convinced it's just nonsense. I refuse to believe that your words mean anything. 11 Plus Network was Mythful, but has now become 11 Plus Network. Okay, good to know. Yes, I do remember you. I recognise your name, Ali Ahnaf Sajid. And Cheryl C, I recognise your name as well. Lovely to see you here. And do let people know that these lessons are now back on and running as normal. We're doing some maths today, so let's get on and do that. We're looking at, I should make this full screen, shouldn't I really? There we are. We're looking, and I should make some more light so this background doesn't look fuzzy. Fantastic. You'd think I didn't know how to stream and I'd never done this before. I'm just in a tearing rush after my last lesson, which overran. So we're looking at some problems to do with algebra. But what I also want to look at today is how, if algebra isn't your strongest suit, you can often actually get to the answers without using much in the way of algebra, and certainly by using a lot of common sense, and a lot more common sense than technical knowledge. So let's start by looking at this one. A bucket and a jug cost £9.74. A bucket and two jugs cost £13.98. And the first thing I want to show you is that you can actually solve this without using any formal algebra at all. So what's the difference between these two statements? What's the difference? So there's no difference in the buckets. They both have a bucket. But there is a difference of one jug. And there's also a difference of 9, 10, 11, 12, 13, 70, 80, 90 and 4. So £4.24. So there's also a difference of £4.24. I'm not going to write the pound sign in during my working, but of course when I write the answer down here, I need to make sure that I've put the pound sign back in. So we've got a difference of one jug and a difference of £4.24. So what must a jug cost? It must cost £4.24. All you've added is a jug, and that's added £4.24 to the price. So a jug must be £4.24. So you look at this thing that looks really complicated, and in fact, just by looking at it with some simple logic, the answer can pop out. I love 11 Plus Network writing. Welcome, get ready to be possessed by Robert's amazing math. I am absolutely not a mathematician, but I think that can help sometimes with these things, insofar as I don't look at these questions from the point of view of somebody who knows a huge amount of high-level maths. I look at them from the point of view of somebody who wants to find practical ways to get to the answers, which is the same situation that you're going to be in the exam. You will definitely get better explanations from somebody who really knows their maths. Of course, you can also look at this a bit more algebraically. So let's start looking at it kind of algebraically, but not with full formality. So let's look at the first statement, a bucket and a jug. So a bucket, we might call it B, and is plus. A jug, we'll call it J. So B plus J cost equals £9.74. Leave out the pound sign during our working. We'll just look at the numbers. B plus J equals £9.74. A bucket and a jug and another jug is £13.98, which can also be written as £9.74 plus £4.24. So what have we added? We've added J. What have we added? We've added £4.24. So J must be £4.24. So that's just a way of representing the same logic, but getting a little bit algebraic. So replacing these ideas with letters and with signs. What happens if you're going to do it in a fully algebraic way? So let's write these out and let's do it formally. So I tend to prefer to put the thing with more large numbers above the one with smaller numbers, and you'll see why in a second. So I'm going to write the second one first. I'm going to write B, a bucket, and plus 2 jugs, that's 2j, so that's 2 times j. We don't write times between the numbers and the letters, we just write 2j. So that's a better way of writing plus j plus 2j equals £13.98. And then I'm going to write the first row, which has got the smaller numbers in. So B plus j, so that's 1 jug, equals 9.74. Now I want to just have j equals at the end, because what I'm trying to find is what a jug costs. So I want to know that a jug equals a certain amount of money. And that means I want to have something without any b's in it, because as long as I've got b's in this, I don't know what j is. So what I'm going to do now, I've got b above and b below, and b, take away b, leaves me with nothing. So I'm going to subtract these two equations from each other. So I'm just going to put this in brackets. It isn't part of the equation, it's just marking what I'm doing. So b, take away b, is nothing there. 2 jugs minus 1 jug, 2j minus j, is just j. That's what we want. Equals £13.98 minus, or 13.98 minus 9.74 gives us 4.24. So that's our answer, £4.24. So 3 different ways of approaching it. One way of approaching it that doesn't require any knowledge of algebra at all. Just looks at the situation, looks at it in a sort of commonsensical way. That's what we did up here. Then there's the way that writes it out using some algebraic notation. So we're putting letters instead of the things, and we're using equal signs, but we're still using the kind of common sense approach. We've added j and we've added £4.24, therefore j must be £4.24. And then there's the last way, which sets it up as what we call a simultaneous equation. So both of these equations are true in the same situation. And then it takes one away from the other and finds out what j equals. Any of those methods is valid. You aren't any less of a mathematician if you do it using the common sense approach. That's also maths. These are different ways that you can approach it. And recognizing that just because a question looks like algebra doesn't necessarily mean that you need loads of algebra to solve it is a really important step in approaching your 11 plus exam with confidence. What does a bucket cost? So we know what a jug costs now. This is part B. It's almost certainly going to use that information. Let's go back to our original situation. Well, we know a bucket and 2 jugs cost this, but really helpfully, we know that a bucket and a jug cost £9.74. A bucket and a jug cost that. And we know that a jug costs £4.24. So instead of a bucket and a jug cost this, we can say a bucket and £4.24 cost £9.74. So therefore, we just need to take £4.24 away from £9.74 to get the price of a bucket. Or we can look at the equation that we set up here and also here in these 2 different ways of solving it. B plus j equals £9.74. So this is the slightly more formal way of doing it. I would use this approach actually because it's very simple and it sets things up very clearly for you and for the person marking your work. So first of all, I'm going to write out that equation. B plus j equals, so an equation is where something equals something else. They are, notice the similarity between those words, equation and equals. B plus j equals £9.74. But now, on the next line, we know what j equals. We also know that j equals £4.24. So we can put this in place of the j there. B plus £4.24 equals £9.74. Excuse my writing, which is rather messy. It's very atrocious. I have no excuse for this. So B plus £4.24 equals £9.74. We don't want this plus £4.24 on the left-hand side of our equation because we just want B equals something. That's what we're doing when we do algebra. We're always saying, what do I want to be in this part of the equation? Which things do I need to get rid of? This thing, plus £4.24, we want to get rid of. How do you get rid of something that's plussed? You do the opposite. You always do the opposite to get rid of something. The opposite of plus is minus. So in the next one, I'm going to minus £4.24. So what do I do? B, £4.24 is gone, because we've got 424 minus 44 is nothing. B equals £9.74 minus £4.24 equals 9.74 minus £4.24, which equals, well, 9 minus 4 is 5, 74 minus 24 is 50, so it's going to be £5.50. Don't do that mentally like I did, because you can make mistakes. Do it as a very quick column subtraction. 9.74 minus £4.24. 4 minus 4 is 0, 7 minus 2 is 5, 9 minus 4 is 5, 5.50. So do it like that, not as quickly as I did it. Make sure you get it right. And then you're golden. Don't forget the pound sign. 5.50. Okay, let's push on. Someone thinks it's £5.54. I don't think so, unless I made a terrible mistake. I like that Hans, my old cat, who unfortunately died several years ago now, but still appears on the Easy 11 Plus homepage on YouTube, is still being brought into people's stories. 11 Plus Network has written, Robert and Hans are in a race. Their legs are aching with fresh pain, each step a testament to their tiredness. In front of them there was Shrek running full speed. Robert grabs a banana peel. Beautifully written. One thing I notice is that lots of young people now are starting to use phrases that are used a lot by chatbots, like ChatGPT. Every step a testament to their tiredness. That's a favourite expression of ChatGPT and Claude. It's funny. I'm not saying you did this with the chatbot. I'm just observing that people are starting to learn to write like chatbots, which is kind of terrifying. But great. Keep going with the Hans stories. Right. Let's push on. Now, this is an absolute classic question, insofar as questions that are basically just different versions of the same problem with different numbers turn up quite frequently in 11 plus exams. Now, what a lot of people will do is they will say, aha, clearly algebra. And so they start doing this. They start writing 2c plus 3m plus s plus 2t equals £18.19. And then they say, c plus 2s plus t equals £12.65. You've got two equations with four variables. Ask someone who's doing GCSE maths or A-level maths who you know why that might be a little bit of a problem. This is not an elegant thing to solve. But maybe you needed to take a moment to look at the question a little bit more carefully. Because you cannot solve these to find out what a cup costs. You cannot solve this to find out what a mug costs. You cannot solve this to find out what a saucer costs. And you cannot solve this to find what a teddy bear costs. You can't solve two equations in four variables like this. There are an infinite number of possible solutions. I'm not going to go into the why of that, it's just a fact. So what is an 11 plus examiner doing, giving you a question that can't be solved? Look at the question a little bit more carefully. Is this question asking you to find out what a cup costs? Is it asking you to find out what a mug costs? Is it, okay, you get the idea, I'm not going to keep going. You've got the point. You don't need to find out any of those things. What is it actually asking? It wants the total cost of one cup, one mug, one saucer, and one teddy bear. Yes, if you could find out the cost of a cup, the cost of a mug, the cost of a saucer, and the cost of a teddy bear, you could then add them all together to get the answer. But you can't. So what's going on here? And that's why I say this is a classic 11 plus question type. Once you know to look out for it, you'll be able to spot it, and you'll be able to steal an advantage over your competitors in the exam hall. When something asks for the total cost, have a look at the question and see whether you can do something like this. How many cups are there? There are 3 cups. How many mugs are there? Well, there are none in the second line, but up here at the top, there are 3. How many saucers are there? There are 3. How many teddy bears do you think there might be? There are 3. So what do we know? We know that 3 of everything costs, well, it's these two things added together, 12.65 and 18.19. So let's add them up quickly. So 12.65 plus 18.19. Let's add them together. Put the plus sign there because I haven't got any space on the left. So we've got 5 plus 9 is 14. 6 plus 1 is 7 plus 1 is 8. We've got the dot. We've got 8.2, so that's 10. And we got 113. So we got £30 and 84 pence. So 3 of everything costs £30 84. Well, this is a much simpler formulation than this here, isn't it? A much simpler way of writing it out. If 3 of everything costs that, then 1 of everything must cost, sorry about my handwriting, 1/3 of that. And what's that divided by 3? Well, 30 divided by 3 is 10. 84 divided by 3, a little bit trickier, but you can always just do a quick division. I've gone blurry. It's 28. So it's £10.28. Don't forget the pound sign. I want to repeat. Look out for questions that look like complicated algebra, but which actually ask you to find the total cost of everything, or one of everything, or something. Often, they end up having this structure, where you actually have, when you put it all together, the same number of everything. And then you just need to add up the total cost and divide it down. I've seen quite a lot of these questions. They're a favourite of 11 plus examiners. Be the person who spots it and not the person who gets caught out by it and tries to solve an unsolvable set of equations. Mega says that is wrong. Says that's wrong. Mega thinks it's 10.26. Well, we can do 26 times 3, so 25 times 3 is 75. 1 times 3 takes it up to 78. So that would be if it was £30.78, not £30.84. So yes, Mega's written my bad. Indeed, you're bad. Right, okay. We've done enough, almost algebra. Now let's do some actual algebra. Because here, you really do need to mess around with some equations. But it isn't too complicated if you're systematic. We've got these fiddly symbols. It doesn't matter at all if instead of curly D, you just write a D. It doesn't matter at all if instead of crazy N, you just write an N, and so on. You don't need to know the names for these symbols. You don't need to copy them exactly. You aren't being marked on that. You're just being marked on whether you get the right answer in the end and whether your working makes sense mathematically. Okay? So anything like this, feel free to simplify. So for example, this curly shape here, if you just wanted to do this, that would be absolutely fine. No problem at all. Right, based on this information, how many D's, I will say, are in one T, I will say. I'm tempted to call it an umbrella, but I don't want to complicate things. I'm going to call it T. How many D's are in one T? So I'm going to talk about D, T, N, and I'm going to call this thing a W, even though it very clearly isn't a W. But that's going to make our life easier. Okay. Based on this information, how many D's are in one T? I got distracted by someone posting a riddle in the chat and then starting to think about it and thinking, no, I should not be thinking about the riddle, I should be doing maths. This is what happens in my English lessons that I do, that I just get distracted by interesting things and then end up rushing to finish the lesson and get through everybody's work. But honestly, they're very useful. Sign up for my English lessons. Based on this information. Right, so what do we know? We know we need to find how many of these are in one T. And there's only one place where T appears here, which is down here. So that's what t is. T is a w and two n's. But how useful is that to us? We need to know how many d's there are. So what we're going to have to do is change the w into a certain number of d's and change 2n into a certain number of d's. So let's just write out what we got here. I'm going to have a go at doing the curly w thing. Plus 2 squiggly n equals t umbrella. But we also know that one of the w's is the same as 4 d's. So we can immediately get rid of the w thing there and change it into d's. So let's do that straight away. Equals means, and always remember this, it's so obvious but it's also so important and sometimes not obvious, that equals means is the same as. So equals means that you can put one thing instead of the other thing because they're the same. Okay? So we can write this instead as 4d plus 2n equals t umbrella thing. And that's good because we want to know how many d's are in one t, and we got a little bit closer. Now we've just got the problem of this 2n there. What do we know? We know this. We know that, I'm going to leave a little bit of a gap because this is a new bit of working. We know that 3, done the other way around now, 3 curly w trident things plus d thing equal n thing. And we also know that 1 curly trident thing is 4d's. We just use that here. We just put 4d instead of that. So let's now put 4d instead of this. So 3 lots of 4d, that's the 4d that we've taken from there, plus d equal n. What are 3 lots of 4d? 12d plus d equals n. What's 12d and 1d? That's 13d. So we know that 13d equals n. We need to put in 2n, but let's start by putting in what we know. So coming from this, and this is not formal mathematical notation, but it does make things clear. So now I'm taking that again, and I'm adding this. In fact, no, I'll add it in the correct place. So we got 4d's plus 2 lots of 13d equals n. As I say, I'm not writing this in the way that a mathematician would, but it does make mathematical sense, and I think it makes it clear when we're talking about 11 plus work, where we're taking this and putting it there, we're substituting in, so adding into the other equation, this 13d, to replace the n. So where we had n up here, 2 n's, now we got 2 lots of 13d. Now we just need to work out all the d's. So we got 4 d's plus 2 lots of 13, that's 26 d's equals n. 4 plus 26 is 30. So 30 d's are the same as n. Sorry, oh no, what am I doing? What am I doing? These are not n's, sorry, these are t's. We're talking about this equation here. I knew what I was doing, I just wrote rubbish, that's the one. Excuse me, cut out that bit of the video, rewind, right. So, has anyone pointed that out? Someone wrote bruh, so I suspect that was because they saw that I was writing the wrong thing. Right, so the answer is that it's 30 of them. Now the only question now is what do we write in the answer space? It says how many d's are in one t. You could write 30d equals t, but all it's asking is how many of them. How many of them? 30 of them. Make sure it's 30 and not 36. Maybe I should just rub out that's nonsense. There we are. So the answer is 30. Let's just recap what we did a little bit there, just briefly. We need to use this to get our answer because we need to find out what equals 1t thing. This is the only one of those 3 equations that does that. So we need to fill in the other half of the equation with d's. But at the moment we've got W thing and two N's. Fortunately, there's another line here that tells us how many D's are in a W thing. So we can substitute, in other words, replace that W thing with 4Ds, because equals means is the same as. So it means you can swap in one thing for the other whenever you want to. So here you can replace that and you can write 4Ds and 2N are T. Now what about the 2N? So we know that 1N is 3Ws plus D, and we know that 1W is 4D. So if 1W is 4D, 3Ws must be 12D. So we know that 12Ds and another D are N, that's 13Ds. So, and now we can put that into the last equation here, and suddenly we have an equation, which is this one here, which has got just a certain number of Ds equaling T, which is what we want to find out. And then all we have to do is work that out. So 2 times 13D is 26D, add the 4D, we get 30, and that's our answer. You could get to the answer here through trial and improvement, through trying out different values. But because there are what? 4? We've got N, D, and W and T. There are 4 variables. There are 4 unknown things here. You might have to try a huge number of combinations before you get a set of values that work. You really do need to solve this. And you do need to know some algebra to do it. It's tricky. It's pushing the limits of 11 plus knowledge. Frankly, it's beyond normal year 6 work at school. And so it's arguably an unfair 11 plus question. But it is the kind of thing that can turn up. And so some understanding of how you do this, not loads and loads and loads of complex algebra knowledge, but understanding the logic of what we're doing, knowing that equals means is the same as, and that you can replace things that are equal to each other in equations, and that we're shuffling it around, a bit like turning a Rubik's Cube, until we end up with just a certain number of D's equaling T, and then we got our answer. It's knowing what you're aiming for that's key to solving equations. If you didn't understand this, don't worry. There are lots of videos about more basic algebra on my channel. Have a look at my video list, which is linked below this, along with the link to my website, and you'll see that there are some videos described as being for core maths or core algebra, and they cover, or basic algebra, and they cover more elementary skills. And when you understand those, you'll be able to move on to stuff a little bit more like this. Right, that's everything that I wanted to cover in today's lesson. So I've got this new resolution to keep these lessons short and sweet. So the last thing I wanted to say is come and try one of my lessons. I would love to see you there, and have a wonderful new year. Enjoy January. It can feel like a bleak month, but it isn't. It could be a beautiful month. And I really look forward to seeing you next week for the next Easy 11 Plus live lesson. Thank you for everybody who joined in the comments. I'll see you again soon. Oh, goodness me. There we are. I'm still getting used to this streaming thing. I haven't done it for 2 months and I've forgotten how it all works. All right, everybody, I'll see you soon. Thanks for joining. Bye.